Hello there and welcome back to this Java collections tutorial. What am I saying? It's not welcome back. It's going to be welcome to this Java collections tutorial since this is the first lesson. We're off to a good start. Anyway, so welcome to this Java collections tutorial. Here we're going to be going over the very basics, or maybe not the very basics, maybe just maybe the very basics, and then the medium of Java collections. So without further ado, let's go and jump right in. So we're going to start off by looking at the collection hierarchy, class hierarchy. So here we can see we have, this is sort of a simplified collection class hierarchy. There are a lot more classes, but this is sort of just sort of the main ones, I guess, if you can say it like that. And as we can actually see here, we have a collection here. So this is sort of the base interface that everything starts from. Now, there is an interface that isn't shown here. There actually is another interface. So up here, whoops, nope, I accidentally clicked there. Collection actually extends the iterable interface, so it's also you know, a different interface. So something to know. And we're gonna go over exactly what the collection interface is in the next lesson, as you maybe just saw that when I accidentally clicked. Anyway, so we have three main sort of ways that the collection interface goes. I guess if I can say it like that, we have the list interface. So, you know, it's just lists. Here we have array lists, vectors, and linked lists. Again, we have a lot of other ones that also extend list or implement list, since list is an interface. But these are the main ones. These are the ones that we're going to be going over. Then we also have a queue, which also extends collection. Now remember, since it is a collection, since it is a interface, it extends another interface. It doesn't implement another interface. That's just something to know. So here with queue, we just have priority queue. We also have DQ, so we're going to look at that, but it isn't shown here since this is, again, a simplified class hierarchy. Now I could have used, you know, a more complete class hierarchy, but I looked at them and I mean I would not be able to create one that would even, I think. The cards would be so little, so small. There would be a ton. You wouldn't understand anything. So I thought it'd be better just keep this simple, and then as we go, we're gonna look at other you know, alternatives that are actually, you know, synchronized, things like that, instead of just putting them all here. Anyway, so we have queue, and then finally we have set as well. So we have a hash set, tree set, linked hash set, and so on and so on. So just generally, this is the basic collection hierarchy. As we go, I may be referring to this diagram of the collection hierarchy. I may be referring to a different diagram of our collection hierarchy. So we may see different diagrams. But don't worry, either way, if you do see a diagram, it's most likely going to be just the collection hierarchy, which essentially just consists of this collection, list, queue, set, and so on and so on. All right, and other than that, then that is all for today's lesson. Really didn't go over much today, but just sort of like the intro to this sort of mini course. So yeah, next time we're going to be going over the collection interface and what exactly that does, and we're actually going to be looking over the code that the collection interface sort of provides. But anyway, without further ado, then I'm going to see you there. Till soon. Hello there and welcome back to this Java collections tutorial where today we're going to be going over the collection interface. So this is going to be sort of the base interface, and if you remember with the the diagram that we looked at in the previous lesson, you will see that everything sort of starts with the collection interface, and today we're actually going to be taking a look at that interface. So before we get into the code, let's go and take a look at the overview. So the collection interface is the base of any collection. It contains the most basic methods that every collection contains. So here we have public interface collection, and it of course is generic, so we can go and input any class that we want into the collection, and it extends iterable because we can iterate over it. So before we get into code, let's also take a look at the methods that collection provides. So we provide, it provides isEmpty, contains, iterator, toArray, add and remove, and etc. But these are the main ones. So of course it doesn't provide them. This is an interface, so it doesn't actually implement these methods. It implements others that are default methods, but essentially, these are essentially the methods that it doesn't implement. So anyway, let's go and take a look at the actual code of the collection interface now. All right, so here we are. We're taking a look at the collection interface code. So here we have, we can see public interface collection, and it of course is generic, so we have an E here. Extends, iterable, and then E here as well. This is just another interface that means that allows our collection to actually be iterated over. So here we have the methods. We can see the actual methods that we return. So size is empty, contains, iterators. This is actually from this iterable interface here. So if we take a look at that, we have public interface iterable, and then we have this iterator method here. Then we also have for each, and then we also have split iterators. That's just something else entirely. We're not gonna, well, not entirely, but just something a little bit different. I'm not going to be going over exactly what that is now. But essentially, you should have already seen these two methods used at least somewhere. Okay, so that essentially is the collection, the basic collection methods. We also have contains all, add all, remove all. Then you also have remove if. This is going to take a predicate as input. This is just going to decide what we're actually going to be removing, essentially. We have retain all. We have clear. So as you can see, that retain all obviously is not very well known, but it retains only the elements in this collection that are contained in the collection that we actually input. So if we go and expand this here, that are contained in the specified collection. In other words, removes from this collection all of its elements that are not contained in the specified collection. So yeah, so if it's not in the collection that we input into the method, it's going to go ahead and remove all the other elements. And of course, this isn't implemented. This is going to be implemented in each sort of implementation differently. Or, well, I mean, I guess this wouldn't really be that differently, but differently. Anyway, then we also have clear, so this removes all the elements from this collection. We have equals, of course, that's just compares the specified object with this collection for equality. So this is sort of like, this is essentially the same as object equals, the default equals. And then we also have the hash code. This is also in all objects as well. So here we have split iterators. So we're not going to go over split iterators right now. So just know that it exists, I guess. Then we also have streams. So this is for Java 8 stream support. So if you don't know what stream is, it's sort of a new way of iterating actually not just iterating, just working with collections. We might be going over that as well. And then we also have parallel streams. This is for streams that will support multi-threading. That's also pretty good. Anyway, so let's go ahead and go over now what we're going to be going over in the next lesson. All right, so next time we're going to be going over lists, which should also be pretty fun. We're actually going to be getting into some actual coding and taking a look at how some stuff actually works and some implementations of the collection interface. So this has been just a short lesson just to sort of take a look at the collection interface. And then next time, of course, we are going to be going over some more advanced stuff. So anyway, without further ado, I'm going to see you there. Till soon. Hello there, and welcome back to this Java collections tutorial, where today we're going to be going over lists. So if you remember from our diagram, lists is one of the main branches in the tree of Java collections. And they're generally very, very well used. So usually when you just need to store something, you're going to be storing it in a list. And usually you're going to be storing it in an array list. So let's go and take a look at what an array list is. All right, so here we are. Array list. So an array list is essentially, it consists of an array plus a list. So it is sort of the combination of an array and a list. So let's go and take a look at the code and show you exactly what I mean by that. All right, so here we are in the ArrayList class. So we can go ahead and take a look here. We have, so first of all, it implements list. It also implements some other stuff, but that's just, it's kind of separate. So we just have serializable, so we can serialize it. We have clonable, so that we can actually clone it. We have random access, which just means that we can randomly access it. So it's all pretty self-explanatory. And the thing that actually makes this an array list instead of just a list is this. Where is it? If we can actually find it here. Okay. No. Where'd it go? Can't seem to find. Oh, there we go. It was right in front of me the whole time. We have element data. So you see right here, we have transient object element data. So this is actually the actual array part of our list. This is the array that's actually going to store our element data. And if we go down to this get method here, so get, let's see where it is. There we go. No, not get. I'm sorry. It's going to be add method, not the get method. There we go. You see that with the add method, first of all, we make sure that our actual array can support the element, actually has space for the element that we're adding. Then if it does, then we add that element. It's actually going to throw an error if we don't. But if we do, then we're going to get element data. We're going to actually set that last index of the array to the element that we're passing in. And of course, we have to pass in a object, so we can't have an array list of ints because our array here holds object. So it has to be some object in order for us to pass it in. All right, so now that we know the essential basics of the ArrayList class, let's go and take a look at some of the big O values for different operations with it. All right, so if you don't know what big O is, it essentially just means that it's sort of a measure of the difference in time that it takes to to perform certain operations with just perform certain operations. So let's just say that we have an array, for example. So to get an object out of the array, it takes what n. I'm sorry, no, it's O1. So getting it doesn't matter. So let's just say that our array has 1 billion values. Getting the object out of it will take the same exact amount of time as if it had 10 values. So that's because essentially what our program does is it just takes we have to pass in an index for it, and it just it applies math to show us to give us the actual part in memory where that array is located, and it just gives us that value from that part in memory. So it doesn't matter if it's 10 or a billion. So it doesn't matter. It does matter a little bit, but not a lot. And essentially, so it doesn't actually increase that much. With a linked list, for example, on the other hand, we're going to go over linked lists in a second here. But essentially, with a linked list, on the other hand, if we have 10 values and we need to get let's say like the fifth element, we have to go element 1, then from element 2, we have to go to element 3, element 1, then element 2, then element 3, then element 4, and then finally element 5, and that takes some time. And after we finally get to element 5, we can then return the actual data inside element 5. If we have 1 billion, on the other hand, and we're getting element 5,000, then we have to go through all the 5,000 different elements, and then finally return the data in number 5,000, which obviously will take a lot more. And so in an array list, performing a get operation is O1, while in a linked list, performing a get operation is ON, which means that it'll take, so in the worst case scenario, it'll take as many operations as it'll take as many operations as there are elements in the actual list. So if there are 1 billion elements, it's going to take, in the worst case, 1 billion different operations to get to the actual element that we need to be at. So that's essentially how big O notation works. I definitely recommend you look it up if you don't know what it is. Read more about it. It's definitely very important for actual programming. Well, not programming, but just if you're going to be professionally programming, it's always good to know. And job interviewers really don't like hiring programmers who don't know what that is. So that's definitely important to know. Anyway, so yeah, in the ArrayList implementation, size is empty, get, set, iterator, and list iterator are all O1, so it doesn't matter how long the array list is. It's going to be how many elements the array list has. It's going to be roughly the same time. As for the add operation, this will run in amortized constant time, so that means that adding n elements requires O(n) times. Essentially what this means is that when we do perform an add operation, if we add 12 elements, it's going to take roughly 12 operations. So essentially this is also sort of like O1, but what's important to note here is that this isn't entirely true, because if we're trying to add an element at the very end and our array list can't support the actual add operation. So if the array is full inside the ArrayList class, the element data array that we just looked at now, if it's full, then it has to go ahead and go over a ton of other operations, and so it's not really O1 time. So that's something that's important to note. And so we're going to take a look at exactly what that means in a second here, and we're actually going to be measuring the time that it takes. But as we'll see in a second here, add a certain index. So let's say that we have an array of 10 elements, adding it at an index of, for example, I don't know, 5. After the 5th index, we're going to add another value. That's going to take O(n) time in the worst case, of course. So that's important to know. So we're going to go and measure the actual difference here in a second. Well, actually, not in a second, really. Just right now. So let's go and measure it. All right, so here we are in our code. So let's go and do system.out.println. System.get milliseconds. Oh no, it's milliseconds, current time milliseconds. There we go. Then what we're going to do is we're going to have ArrayList integer equals new ArrayList. All right, there we go. And let's add integer here as well. Make it generic. There we go. Perfect. Whoops. Nope. We got to put the parentheses before. Don't know why I did that. There we go. All right. Perfect. And of course, I forgot the name. I forgot how to type today. ArrayList integer. Let's just say ARR. Remember, if you're actually programming, never do this. Never name variable X or Y or ARR or something like that or str. That's just it's bad. But I mean, since we are showing an example here, I guess there's really no better way I can name it. Well, I mean, maybe there is, but really no point either way. Anyway, so what we're going to do is we're going to measure. So we're going to do system.out.println system.current time milliseconds. Then what we're going to do is we are going to go ahead and do for int I equals 0, I is less than 100,000. Or let's just do a million here. This is a million, right? Yeah, a million. And then I++. There we go. Okay. And so here in ARR, what we're going to do is we're going to do ARR.add. And I don't know, let's just say ARR.add. Why not? Because why not? Okay, there we go. Perfect. Then here what we're going to do is system.out.println system.current time milliseconds. There we go. And then what we're going to do here is for int I equals 0, I is less than a million again. I actually think that might be a little too much. Let's just keep it at a million, and we'll see. We'll adjust as we go. I is less than a million again, and then we're going to do I++ there as well. And here we're going to do ARR.add. Whoops, not at all. We're going to do .add, and here what we're going to do is we're going to do I, comma, and here let's just say that we're going to add it at the third spot. So, and then here we're going to do system.out.println system.current time milliseconds. All right, there we go. So, and then finally, let's go and delete this system.println up here since we don't really need it. All right, and there we go. And so now this is just going to print the current time in milliseconds at every single operation that we do here. So let's go and print this, run this, not print. All right, there we go. So we got our first two. So you can see this took what, 45 milliseconds. So this took 45 milliseconds. Okay, so we got some weird. We got some weirdness going on here. Let's run this again because that's odd. Okay, everything seems to be going good as of now. But as you can see, this operation with ARR.add I, 3 is taking a very long time. So as you can see, it prints the second system.current time milliseconds pretty fast. So we got 672 and then 718. So that's what, 100 milliseconds of difference? Less, a lot. That's a lot less. That's what, 40, 50 seconds. Or no, it's actually going to be less than 50. It's going to be 46. I think it's 46 milliseconds of difference here. And there we go. And finally, we got 42. I don't know why it's printing 42. It's odd that it's printing this. I'm going to take a look at exactly what's going on here. All right, so I'm not 100% sure why I was printing 42 there. Either way, so right now we have, I took things down to 10,000 just to make it all a little bit more understandable. Let's also do long time equals, and then do current system.get.current time milliseconds. There we go. So let's get that. Then let's put that here and then here as well. And then here we're just going to do system.current time milliseconds. Whoops, we're going to leave the time here. Current time milliseconds minus time. There we go. And then here we're going to set time to system.current time milliseconds. And then here we're going to do minus time as well. All right, there we go. So now let's go ahead and run this, and we're going to get, there we go. So as you can see, this operation running it 10,000 times take 3 seconds, or 3 milliseconds, and this takes 18 milliseconds. So if we run this again, you're going to see that we're going to get pretty consistent results. So it's going to take roughly just more time, a lot more time to do this. If we go ahead and change this to 100,000 times that we're going to do this, and you will see you will maybe hear my computer fan spin up here since it is doing some pretty complex math. You can see now that it actually goes up very fast. So as you can see, we get exponentially, I think. So we get 2,220 milliseconds here. So that's 2.2 seconds here, or roughly 2.2 seconds. And it's still just 10 milliseconds here. So as you can see, it's a pretty drastic difference. So that's because here, when we do this, what it needs to do essentially is to move all the other elements in the array down. So if we add I to the third place in the array, so it has to move all of the other elements in the array down quite a bit. So as you can probably imagine, that takes a lot of time, and as a result, adding to a certain index in the array takes a lot longer than adding to the end of the array. But other than that, then, that is all for ArrayList. Now let's go and take a look at linked lists. Alright, so here we are. We can take a look at the linked list. So this is essentially just a doubly linked list implementation. So if you don't know what a linked list is, it essentially just means that we have an element. So for example, let's just say that an object. And that object just links to the next part in that object. And then that next part in that object links to another next part, and then so on and so on. So essentially, in result, we get sort of like a linked list, which essentially is what it's called. And the difference between a singly linked list and a doubly linked list is that a singly linked list has each sort of object in the list is called a node, and a singly linked list is, just links to the next node. So once you go to the next node, for example, or actually not for example, just if you go to the next node, you can't go back to the previous node. A doubly linked list, on the other hand, once you go to the next node, you can go ahead and go back to the last node, and then go back, and then so on. So you can go back or forward in a doubly linked list, but you can only go forward in a singly linked list. So that's just sort of something to know. And so the linked list has add, next, and remove operations. They are all O1, which makes sense. So essentially with a linked list, adding something is very simple. So you just, the previous element, you just do previous element dot next element equals the element that you want to add. And then the element that you want to add, dot next element, just equals the last element that we removed. The next element of the element that we just set the new element to the next element, essentially. I'm not going to go into exactly what the linked list is. We're just really going over more about how it works in Java. But yeah, and then also the remove as well. It also takes O1 time. With the linked list on it, though, get and contains take ON. So if we want to check if we want to get something, we have to actually go through all of those sort of, go through every single node. So if we want to get the node in the half of the list, we have to go through all the previous nodes before that. And with contains, the same thing. So you have to go through all nodes and check if it actually contains the object. So let's actually go ahead and take a look at how we can use the linked list and where it actually differs from ArrayList in terms of time. All right, so here we are. As you can see here, let me actually take this back to 10,000, down to 10,000. As you can see here, when we run this, so this is still with ArrayList, you can see here that we go ahead and get 1 and 10, 10 for adding it at a certain location, and 1 for just adding it. Now, in linked list, let's just change this to linked list here. There we go. Let's go ahead and import linked list. All right, and now let's run this. You'll see that it actually changes quite a bit. So now we get 85 instead of 1. Instead of the 10 that around 10 that we were getting previously. So why does this happen? Well, this is because in a linked list, when we add something at a certain location, first we actually have to get to that location. So while adding it doesn't take much time, in order to add it to, actually add it. So when I mean actually add it, I mean, set the last element to the current element, set the previous element that we're going to be adding it after to the current element, and then set that element's, and then set our element's next element to the element that our previous element was pointing to before. And so in result, that takes, very little time. But actually getting to that element, on the other hand, that takes quite a bit of time. So if we first have to go to the first element, then we have to do first element dot next, and then dot next, and then dot next, and so on and so on. And in result here, this actually takes quite a bit of time to perform. So that's just something to note. So the same thing if we were to do get. So if we were to do arr.get, for example, I here, you'll see that this actually takes a lot longer than add. So let me go and run this. There we go. So you can see here we have 2, and here we have 46. So getting an element takes a lot longer than adding an element in a linked list, which makes sense. Now, where a linked list shines, of course, is if we have to, just add an element at the very end. So that, of course, is handled by the actual linked list implementation. I don't really know how it's handled has anything to do with it, but we just add it to the very end. We set the last element to the current element, and the current element to the next element. So that essentially, of course, takes very little time. Now, linked list generally it isn't very time efficient, just because as you can probably imagine, we have to go through every single element again and again and again. So definitely ArrayList is, for that reason, is a lot more used, or used more. So yeah, definitely something to know there. Where the linked list shines, on the other hand, is with removing. So if we go ahead and create a linked list here, and then create an ArrayList here. Whoops, let's create an integer. ARR2 equals new ArrayList integer. Let me go ahead and copy this. All right, there we go. And now if we were to go ahead and let's do this, and let's just copy this in here. We're going to do the same thing pretty much. Let's remove this to time. There we go. All right, and here we're going to do ARR2. So first of all, we're going to add a bunch of elements, and then we're also going to remove those same elements. And we're just going to compare the times. So if we go ahead and run this now, all right, we actually get an error here. Let's take a look here. Okay, I see what's happening. So since we are actually removing elements, every single time we remove an element, the amount of indexes becomes less and less. So and the number that we're actually removing becomes more and more. So here, instead of just all we have to just remove, we can just do 0. And then that will just do the same exact thing. So now we're going to go ahead and do that. There we go. So this takes, as you can see here, removing an element takes the exact same time as adding the element, so just 2 milliseconds. And then here we're also getting the exact same problem. So here we just have to arr.remove 0. And now you can see here how removing in the linked list, removing all elements takes 2 milliseconds. And removing in the array list takes 5 seconds, and even though we're doing the exact same operations. That's essentially where the linked list shines. So now if we were to go ahead and increase everything here, so let's just increase it from 1 to 5 just to show you the extent here. You can see now that it is much more dramatic. So now it takes 3 milliseconds to remove all 50,000 elements, while with the array list it takes 113 milliseconds, which is a very large difference in time. All right, and now we went over the array list, we can finally take a short minute to go over the vector. So I'm not going to really go over the vector in detail. We're not even going to program anything with the vector because it's pretty much outdated. So it isn't actually deprecated yet, but it is actually outdated, and it really isn't a very good solution to solving the problem of an array list. So the problem with an array list is that it isn't synchronized. So the vector was created sort of like to synchronize a array list, but it wasn't synchronized very well, and the synchronization that actually it actually included didn't really work very well, and you still had to check to make sure that it was synchronized, even though it had built-in synchronization. And in result, it just sort of isn't really used. But other than that, it's pretty much an array list. It has synchronization logic that really doesn't really work very well. I mean, it works like it's supposed to, but just the way it's supposed to work isn't very good. So yeah, that's why I'm not that's why I'm not going to cover it. There are other ways to get a synchronized array list. We're not going to go over synchronization per se as of now, but perhaps near the end of the lesson, we're going to take a look at the very basics. It's just that when you get into synchronization, everything starts to get much more complicated, and as a result, the amount of time it takes to explain things takes a lot longer. So that's why we're not going to be going too deep into it. But just know that it exists. It's just not very well used. It's an ArrayList, but it's synchronized. That's all you need to know. And other than that, that is all for today's lesson. Next time we're going to be going over the queue interface and taking a look at the absolutely massive applications of it. We can do a lot of things with the queue. That's sarcasm. But anyway, you're going to see exactly what I mean in the next lesson. I'll see you there. Till soon. Hello there, and welcome back to this Java collections tutorial, where today we're going to be going over the queue interfaces. So if you don't know what a queue is, we can take a look here. A queue is essentially, you can think of a queue as a line in a grocery store. So the first element that is inserted is the last element to be removed. So you know how in a line at the grocery store, you get in, and then once you are actually in, once you are inserted, you have to go through the entire line until you're actually removed from the line. And so in result, with a stack, which is, sort of the opposite of a queue, when you're inserted, you're also the first one to go out of the stack. So if a grocery store line worked like a stack, essentially somebody would get in a line, and then if you just got in and the cashier is available, then you get out of the line immediately. And so essentially, if you get in the line and then another person gets in front of you, then the person that gets in front of you is going to get to use the cashier, first. He's gonna make his purchases first. And so we can actually see that here with the cute little diagram here. So when we enqueue something, it goes to the very back, and then after finally it moves up to the front, it's dequeued. So essentially, it implements the first in, first out structure, which differs from the stack, which implements the last in, first out structure. So they're just a little bit different. But that essentially what a queue is. So we have two queue implementations in Java, or two main ones, and that is the priority queue and the linked list. So you may be telling yourself, wait a second, we've already gone over the linked list. It's not a queue, it's a list. Well, while it is a list, it can also be used as a queue, since it does also implement queue. So let's go and take a look at how we can use the linked list as a queue here. All right, there we are. So first of all, I got some facts here about the linked list that just generally help. So it can contain duplicate elements, so we can go ahead and insert, duplicate elements into the linked list. It maintains insertion order, so that means that if we actually give it, something like a insert 1, then 2, then 3, and then print the linked list, it's going to print 1, 2, 3, essentially. So that's definitely that's what maintains insertion order means. It's non-synchronized, so there's no synchronization with linked list. Manipulation is fast because no shifting needs to be occurred. This is what we took a look at in the previous lesson when we did our insertion tests. So that's also something. It can be used as a list, stack, or queue. So in the previous lesson we used it as a list. It can also be used as a stack and a queue. In this lesson we're going to be taking a look at using it as a queue. And here we also have inherits methods from list, dequeue, clonable, Java I/O serializable, and abstract sequential list, which it's not an interface. It's an abstract class, but that's also it also inherits methods from there. All right, so that is essentially just some fun facts essentially about the list. Now let's go and take a look at how we can actually use a linked list as a queue and how exactly the queue works in Java and really in any programming language. All right, so here we are in our code here. So we still have the code from the previous lesson. We can go ahead and delete it and just keep this linked list here. And you'll see here now, if we try to do ARR and do something like peek, you see we can now actually use peek, the peek method. If we try to do something like poll, we can also do that. This essentially is actually what allows us to use a linked list as a queue. So let's show off how a queue works. We can do arr.add. Let's just say 1, then arr.add. Whoops, nope, not add. Wait, let's just do add. 2. All right. And now what we're going to do is we're going to do system.out.println arr.peek. All right, let's take a look at what it prints when we peek. And as you can see, it prints 1. So what peek essentially does, we can actually go ahead and do do that. And there we go. Retrieves, but does not remove the head, first element of this list. So you can see here how we first of all insert 1. So right now the order of our linked list here is 1, 2. 1 being the head. So when we do peek, what it does is it just returns the head, but it does not remove it. If, on the other hand, we do pull, P-O-L-L, you can see here retrieves and removes the head, first element of the list. So right now if we do peek, and then do system.out.println, arr.size, you'll see that we're going to get 2. All right? So here we go. The size is 2. What do we change this peek to pull? Now what we get is 1. So it retrieves and removes the first element. Now if we do arr.size, instead of arr.size, we do arr.pull, we can now get both elements from the list, and our list is now empty. So we got both elements in their given order. So that's essentially how the linked list works. Now there are a few other methods that are only in queue, and we can actually see some of these, or all of these methods, if we actually just do change this linked list integer to queue integer. All right, there we go. And now we can go ahead and go to the queue interface, and there we go. So you can see these methods that we have. We have add, so we already took a look at that. That's pretty self-explanatory. Next, we have offer. So offer differs from add because whenever we can't insert an element into the queue, let's say just because of capacity, so the queue has reached capacity, what add will do is it'll throw an exception if we can't do it. Offer won't actually throw any exceptions. It'll just return false if we can't do it. So that's the difference between the two. We also have remove. So what remove will do, remove is essentially the same exact thing as pull. So it just returns the head of the queue, and then also removes the element from the queue. The difference, of course, between remove and pull is that remove will actually throw an exception if it can't remove, if there are no elements, and pull will just return false and not throw any exception. Next, we also have the element and peek methods. So they're also very similar. Well, I mean, they're pretty much the same. So both of them, what they do is they just return the head element of the queue. And the difference between them is that element will go ahead and throw an error if there is no head, and peek will just return false if there is no head. Simple as that. And there we go. Those are all of the methods in the queue class. All right, so now that we went over the queue interface, we can now actually we also went over how to use linked list as a queue. So we see here how we have arr.add1 and then arr.add2. And when we run this, we get, let's save it, of course, 1, 2. And what's important to note here as well is that if we do 2 and then 1 here, then we're actually going to get 2 and then 1. So it keeps its order of insertion when actually getting a result. So you're going to see why this is relevant in a second here when we go over a priority queue. All right, so a priority queue, first thing to note about it is that it doesn't allow null, so you can't insert null into a priority queue. The elements of the priority queue are ordered according to their natural ordering or by a comparator provided at queue construction time, depending on which constructor is used. So what this means is that priority queue doesn't actually keep its original order of insertion. So if we insert 2 and then 1 and then print the priority queue, we're going to get 1, 2 since it's actually going to sort the elements naturally. Or we could actually give it a comparator, which essentially just is a data structure that allows us to compare to, well, not really a data structure, it's an object that allows us to compare to different values, and it uses that to sort of sort the priority queue accordingly, so just to sort it. So yes, those are the two ways, but it does not keep its order of insertion. The queue retrieval operations pull, remove, peek, and element access the element at the head of the queue. So, I mean, that's pretty simple. It inherits methods from abstract queue, abstract collection, and the object class, which obviously. All right, so that is in general is the priority queue. So the two most important things to note here is that it doesn't allow null, and about this order of the elements sorting, which is actually what we're going to be going over in more detail right now. So let's go and get into that. All right, so let's go and change this linked list to priority queue. There we go, and let's import priority queue. There we go, perfect. So now we can go ahead and you're going to see here, first of all, when we print arr.add2 and then arr.add1, we're now going to get 1, 2. So even though we added 2 first, 1 becomes the head because it orders it according from least to most. So if we were to, add in a whole bunch more here, so let's say that we had 3, 4, 5, 6, 7, and then run this. All right, we only do it twice. So let's add in some more system.println here. You're gonna see that we're gonna get 1, 2, 3, 4, 5, 6, 7. So it's actually going to order it naturally. And same thing goes if we actually put in strings. So let's say we put HH here, then here we put TT, then JJ, and let's keep it at 3 because why not? And then here we're going to change this to string, of course. All right, there we go. And let's keep the prints down to 3. There we go. And now you're going to see when we run this, we get HH, JJ, TT. So it actually orders it according to alphabetically. So in this case, HH is first, then JJ, then TT. And so that's actually how that works. Of course, we can also actually add in our own comparator, as I said, which will allow us to actually decide how we want our array to be sorted. So to do that, all we're going to do is we're going to go to this priority queue, and in the constructor here, we're going to do new comparator. All right, let's go ahead and import comparator. There we go. And now, in theory, we should just be able to do this and then add an implemented methods. And let's add a generic to our comparator, generic type. So we're going to make it string. There we go. And now we can do compare string object 1 and then string object 2. So what's going to happen is when it, for example, adds in this TT, what it's going to do is it's going to go in and call this compare method. And if it gets back a negative number, it's going to put TT first. If it's going to get a positive number, it's going to put TT after HH, essentially. And it's going to pass in TT as object 1 and HH as object 2. So let's go and do this right now. So we're going to do system.out.println. We're just going to print 01 equals plus 01 equals plus 01. There we go. Plus space 02 equals plus 02. All right, there we go. And then also we're just going to do what we're going to do here is just return 01. Let's return 01 dot charat 0 minus 02 dot charat 0. There we go. All right, so now let's go and run this. Let's see what we get. Okay, so as you can see here, when we add TT, it compares TT with HH, and in this case, it subtracts subtracts T minus H, which gives us, I think it gives us a negative. I'm not 100% sure. Can't really, I don't remember all of the integer. But yeah, it should give us a positive here since we are subtracting it first. Yeah, so it should give us a positive here. I think positive 12 or something. So let's actually, we can actually go ahead and print out what the result that we get by just doing that. There we go. All right, and as you can see here, we get, positive 12. So in result, it puts TT after the HH. And then when we call JJ, first of all, it compares JJ with TT, which gives us negative 10. So it puts JJ before the TT since it is a negative. And then after that, it compares the JJ with the HH as well. So it goes up. And since it gets a positive here, it puts the JJ after the HH. And there we go. So this is what we get in results, HH, JJ, TT. So we wanted to actually sort this in the other way, so make it from, you know, inverse it alphabetically. So make it Z to A, essentially. We would just do O2 minus O1. And let's change that here as well, O2 minus O1. And now you're going to see that we get negative 12 here since it subtracts h minus, so it subtracts h minus t, which gives us negative 12. And then same for j, so j minus h, h minus j is going to be negative 2, and then t minus j, it's going to be 10. So as a result here, you'll see that when we print it, what we actually get is tt, jj, hh, so it sorts it unalphabetically, so the opposite way around. All right, so other than that, that is all for this collections mini course in Java. I hope you have a clear idea of how to actually use collections in this programming language. Just to summarize, in this tutorial, we covered the class hierarchy, the collection interface, so the interface that all collections implement. We covered also lists and queues. So there are more topics that we can cover in collections. So we can cover maybe maps, we can cover sets, we can cover maybe some functional programming, using streams and collections. We can even cover something like we can take a look at more operations in collections and the time complexity, the computational complexity of those operations. We can take a look at synchronized collections and so on and so on. So there is more definitely that we can do, but it's been sort of like the very basics. If you want to see more content regarding Java collections or maybe something else, be sure to leave it in the comment section below. That's really the best way to leave feedback on what you want to see. And other than that, thanks for watching. Make sure to subscribe. We have new videos 6 days out of the week. And I'll see you soon.